Okay, I call this atomic orbitals, aka fun with balloons. Now, I'm trying to show you the shapes of the orbitals and give you some sort of a feeling about how they stack. So 1s orbital is a sphere. Let's call this a small little 1s orbital. That corresponds to the first period on that periodic table that I gave you, the colored one. So that 1s orbital is all hydrogen and helium have. Now if you get onto the second period, the first two elements, that's lithium and beryllium, they have a 1s orbital and a 2s. Now, I don't know if you can see, but there is a 1s orbital inside my 2s orbital. I don't know if you can see that or not. Hopefully you can. All right, I blew a balloon inside a balloon just for fun. I couldn't do two balloons inside a balloon to give you a 2s and a 1s inside a 3s. But as we go across the period though, the second period, we start to hit things like boron. Boron has p orbitals. So p orbitals look like dumbbells. So they also, I'm putting on the letters for the orbitals. So there we've got 2px, 2py, 2pz, but they don't exist like this in 3 dimensions. See if I can get these put together without popping them. That's always the key thing. Come on. There we go. Do you see how they're, whoops, except the wrong sides. These two are on the wrong sides. There, now we got it, right? So you've got your 2py, the purple one. You've got 2pz, the orange one. And you've got 2px, the green one. Now inside that, centered, the nucleus would be where the balloons all intersect. You would have jammed in there a 1s and a 2s orbital. Now, these aren't really drawn or shown to scale. The 1s and 2s would be bigger. It'd be a slightly smaller than the extent of the 2p, the 2s would be. And then if you go to the next period, you go down to the third period, and you get down to, I don't know, sodium and magnesium, there's going to be a 3s. And that 3s, again, this isn't to scale. The 3s will be around these two, and then you'll get 3p, which will be even bigger than the 2p. So you end up with these things all stacking on each other with the nucleus at the intersection of all the balloons.